These few examples will help you through your assignment, which I'll give at the end of these examples. And the first one is, suppose this is the example. This example will be true for number 1, 2, and 3, which you can only see number 1 right now. The integral from 0 to 1 of e to the x dx equals e minus 1. One day you'll actually be able to calculate that, but for now it's just given. So understand that this is just a given value, and it is true. The integral, the area under the e to the x curve from 0 to 1 dx is e minus 1. Now we can use properties of integrals to find this value right here. And that is asking us to find the integral from 1 to 1. The integral of 1 to 1 of e to the x plus 2. So I noticed I added a plus 2 here, but you know what? I don't even care because I see right here this situation, the integral from 1 to 1. So that's just like the integral from a to a. There is no area under the curve from one number to itself. So that answer was quick and easy, 0. All right, the second one is going to take a little more work, but not much. And on this one, we're going to take the integral. Once again, it's given and understood. The first part is still the integral from 0 to 1 of e to the x dx is e minus 1. On number 2, we have to use that fact to find the integral from 0 to 1 of 3 minus e to the x dx. Now this requires us to remember that the integral of a sum is the sum of the integrals. So I can rewrite that as 2 integrals. The integral from 0 to 1 of 3 dx minus the integral from 0 to 1 of e to the x dx. Now I can find a value for that. You say, well, you didn't give me the integral from 0 to 1. From 0 to 1 of 3. But this is one that anyone can figure out when they think of what that means. It's as if we have a curve at y equals 3. At y equals 3, we have a straight line. So we're interested in the area under that curve from 0 to 1. So if this is 3, and that's a constant straight line, y equals 3, the area from 0 to 1 is just simply 3 for height, 1 for width, and we get 3 times 1. So that area is just 3. So this value is 3. And we get to this value. This part, the integral from 0 to 1 of e to the x is what was given in the beginning, e minus 1. We've got some parentheses to remove. And so we get 3 plus 1, 4, minus e. So there we have the answer to that one. Let's go to the last example, and this should get you set that you can do your work. And this one is, let me remove this. If you still need it, just pause the video. Alright, this one says the integral from 2 to 3, which initially seems troublesome because the one that I gave you was from 0 to 1. But we had a principle, remember that one where we shifted the curve c over? Is this not a shifted curve? It is. Notice right here, hugging the variable is the negative 2. So that tells me that the curve has been shifted 2 to the right. So therefore, I can say that that's going to be equal to the integral of 0 to 1 e to the x dx. Remember how we can add, if we shift the actual curve 2 to the right, then we have to add 2 to these integral limits of integration. Did we not? 0 plus 2? And 1 plus 2. We did. So we learned that when you took a curve and you shift it over and you also shift your a and b equal amount, that those values are equal. So therefore, this one equals what was given, e minus 1. All right. Let's see if there are lots of ways you can use these properties of integration. and I will definitely, there's definitely some in your homework that I have not showed you, but you have the ability to apply them. So here we go. Look down, and you're going to have to get, one of you have to get your book. You can copy the page, so you don't have to lug the book around or whatever works for you. But here is the assignment. The assignment is, see if it's on the screen, and out of the shadows. The assignment is section 4.3, number 34 to 40 even, and then number 41 to 44 all. Now those have 4 parts, A, B, C, and D, and I want them all done. Alright, so that's the end of our class for the teaching part. The rest of the hour, what's left, you can use to work on this assignment, and I will be checking up on you and see how that goes tomorrow. So, hope it goes well. See you then.